Immunology Insights, Basics and Beyond, Chapter 6, Monocytes and Macrophages. Marcello here. Welcome back to Immunology Insights, Basics and Beyond. In our previous chapter, we explored the roles of neutrophils, eosinophils and basophils in the immune response. Today, we will delve into two other crucial players, monocytes and macrophages. These cells are often referred to as the immune system's versatile warriors due to their ability to adapt to various roles in maintaining tissue health, fighting infections, and bridging the innate and adaptive immune systems. So let's talk science. Let's start with monocytes, the circulating sentinels and precursors. Monocytes are a type of white blood cells that circulate in the bloodstream, making up about 5 to 10% of the body's leukocytes. Produced in the bone marrow, monocytes circulate in the blood for about 1 to 3 days before migrating into tissues throughout the body. Here, they differentiate into macrophages or dendritic cells depending on the signals they receive. Monocytes are often described as the immune system's scouts or sentinels, constantly patrolling the blood for signs of infection or injury. When they detect such signals, they quickly move to the affected area. Monocytes are capable of phagocytosis, the process of engulfing and digesting pathogens, dead cells or other debris, making them a key component of the body's first line of defense against infection. But monocytes are more than just precursors. While circulating, they actively respond to infections or injuries by producing cytokines, signaling molecules that modulate the immune response. These cytokines can either enhance the inflammatory response to fight off an infection or help resolve inflammation and promote healing. Monocytes also play a role in regulating the immune response, helping to ensure that inflammation is appropriately controlled. Now, let's come to the macrophages, the tissue-dwelling guardians and big eaters. Once monocytes migrate into tissues, they differentiate into macrophages, larger and more specialized cells found in virtually every tissue in the body. Macrophages are known by different names depending on their location, such as Kupffer cells in the liver, alveolar macrophages in the lungs, and microglia in the brain. Macrophages are the immune system's professional phagocytes. Their primary function is to engulf and digest a wide variety of targets, including bacteria, viruses, dead cells, and cellular debris. This cleanup function is crucial for maintaining tissue health and preventing chronic inflammation. But macrophages do more than just eat debris. They are also key players in orchestrating the immune response. Macrophages can present antigens, which are pieces of pathogens or other foreign substances, to T cells, thus bridging the innate and adaptive immune systems. This antigen presentation is essential for the activation of the adaptive immune response, which leads to the development of immunological memory and long-term protection against pathogens. Macrophages are also able to polarize. One of the most intriguing features of macrophages is their ability to adopt different functional states known as macrophage polarization. This versatility allows macrophages to adapt their responses to different situations. The two main polarized states are: first, M1 macrophages, which are pro-inflammatory. Activated in response to pathogens or inflammatory signals, M1 macrophages are potent killers of bacteria and viruses. They produce pro-inflammatory cytokines like tumor necrosis factor alpha and interleukin-1 beta, or TNF-alpha and IL-1 beta respectively, which are essential for fighting infections but can also contribute to chronic inflammation if not properly regulated. Second, we have M2 macrophages, which are anti-inflammatory. Associated with tissue repair and wound healing, M2 macrophages are activated by signals like interleukin-4 and interleukin-13, or IL-4 and IL-13 respectively. They produce anti-inflammatory cytokines like interleukin-10 and transforming growth factor beta, or IL-10 and TGF-beta respectively, helping to dampen the immune response and promote tissue regeneration. This duality makes macrophages both powerful defenders and potential contributors to disease. For instance, While M1 macrophages are effective at killing pathogens, excessive M1 activity can lead to chronic inflammatory conditions such as rheumatoid arthritis. Conversely, M2 macrophages, while essential for healing, can sometimes support tumor growth by creating an immunosuppressive environment in cancer. Next, let's look at the role of monocytes and macrophages in various diseases. Given their central roles in immunity and tissue homeostasis, monocytes and macrophages are involved in a wide range of diseases. First, infectious diseases. Infections like tuberculosis are characterized by the persistence of pathogens within macrophages. Mycobacterium tuberculosis, for example, the bacterium that causes tuberculosis, can survive inside macrophages, evading the immune system and leading to chronic infection. Second, chronic inflammatory diseases. Conditions like arteriosclerosis involve macrophages that engulf lipids and become so-called foam cells. These foam cells accumulate in arterial walls, contributing to plaque formation and cardiovascular diseases. Third, cancer. In the tumor microenvironment, macrophages can be co-opted by cancer cells to support tumor growth and metastasis. Tumor-associated macrophages, or TAMs, which often resemble M2 macrophages, can suppress the immune response against the tumor, making them thereby a good target for cancer therapies. Fourth, autoimmune diseases. In diseases like multiple sclerosis, macrophages contribute to the destruction of myelin, the protective covering of nerves, thereby leading to neurodegeneration. To conclude, let's recap the essential roles of monocytes and macrophages, as they are indispensable players in the immune system, serving as both guardians and warriors. Their ability to adapt to different roles, from fighting infections to healing tissues, makes them versatile and essential for maintaining health. However, their involvement in various diseases also underscores the complexity of their function and the importance of regulation within the immune system. In our next chapter, we will explore the dendritic cells, another key player in the immune system, and their role in bridging the innate and adaptive immune responses. Stay tuned as we continue to unravel the complexities of the immune system and its remarkable ability to protect us from harm. Before closing, I have a small request. If you enjoyed my content and want to hear more, like and subscribe. It's a small step for you, but it helps me a lot. So see you next time, and thank you for listening.